So this is a gyroscope.
Turn right.
And speed. Uh-oh.
That's bad.
There we go. Okay, so this takes a moment to get up to speed. Are you getting sleepy?
No.
Katie, are you getting sleepy? You're already sleepy. And what I'm going to do in a moment is I'm going to take this weight and I'm going to hang it on the front of this. And when I hang it on the front of that, that little nose is going to angle down a little bit. And when it angles down, this whole assembly is either going to rotate this way or it'll rotate this way. So the question is, which way is it going to rotate, and why would it do that at all?
Which way?
The raffle ticket is not for telling me which way it's going to rotate, because half of you would say one way and half of you would say the other way. The raffle ticket is for explaining correctly why it rotates in the direction it rotates. So I'm going to let you think about that for a little bit. Let's see, I'm going to go with Aiden, I think. What do you think, Aiden?
So right now it has a vector that's facing towards me to myself.
Okay.
Towards the class. And if you would put a weight on it, it would want to conserve that vector, which is not really going to happen, but it's going to rotate. You're pushing that vector downward, basically. So it's
This one's going to go down.
Yeah, it's going to. This system's going to want to rotate in a way that pushes it back upwards, which would be rotating, from your perspective, be counterclockwise, going down on it.
Okay, so you say this is going to go this way, or this way?
That way. Yes.
This way? Okay, so let's see if you're right. You're right. Okay. So let me see if that's a good explanation. This is hard to understand without a drawing. So let me do a little drawing. I'm going to rotate this so that the original vector is pointing that way to your right. Okay? So if I do that, this is the direction of the angular momentum vector. Everyone agree with that? You too, Lindsay?
Yeah.
Okay. So that means that if I do an internal torque like she suggested, that's still going to be the direction of the angular momentum vector. Right? It has to be. But when I put this on here, that little metal thing that was poking out at you is now going like that. It's pointing down. But this has to be the original, that still has to be the direction of the angular momentum vector. So that means there has to be another angular momentum vector, that when I add it to this one, I get that one. Okay? So here it is, like so. Now if you put your thumb in the direction of that angular momentum vector, try it, you get rotation like this. That is why this is spinning like that. Is that what you were thinking, Aiden? Yeah. Do you remember earlier when I hung the bicycle wheel from the cord and it was rotating like this? That's why it was doing it. Because when I was holding it at the end of the cord, the bicycle wheel had some weight, and so it acted downward. And it tried to compensate to make that original direction of the angular momentum vector by creating another angular momentum vector facing out.